Hi, my name is Ritik Parandla, and I'm a data science student. My ID number is 020742110, and I will be giving my final project demonstration today. Okay, so my final project is based on the machine learning. It is classification of emails by using machine learning algorithms. So we have a brief introduction over here. We have a couple of points that we need to get through over here. So, introduction. So, what are spam mails? Spam mails are also known as non-self unsolicited, the malicious emails that are sent to us, to an individual or corporation or group of people. Spam mails are also always in a commercial and very driven by financial motive. All the spam mails that we get are usually on a marketing strategy, and spammers try to promote all the goods and other make the false claims and they deceive recipients into believing that something that is not true. So the type of spam mails over here, which is the phishing mails, email spoofs, text support scams, current event scams, advanced fee scams, and malicious spams. The malicious spams contain viruses and like trojans which will affect your laptop and your personal computer. The main objectives of this is to an unsupervised approach to for the email detection to eliminate the problem of labeled data sets. The spam mails are considered as anomalies to frame the spam mail detection as an anomaly detection task. And LSTM is also a machine learning algorithm. Alan code is also an algorithm which is used to represent the spam and ham mails, which is ham is 0 and spam is 1, which is the binary codes of each. To demonstrate a comparison between the performance of the proposed model for supervised learning, which is a naive based. LSTM is a very unsupervised approach of this. So to do this project, you would need an IDE or Visual Studio Code and libraries such as TensorFlow, NumPy, Pandas, sklearn, scikit, and your machine. So detection of spam is done. In this case, a machine learning model must be able to determine whether the sequence of words found in an email is closer to those found in spam mails or a safe one. So it will try to compare between the normal emails that we get and the spam mails. In case of spam mail detection, things get more complicated. Our target variable is whether a given mail is spam or ham. And the features of these words are these combinations found are in the email subject body or just the email body. Once the data is processed and assigned to the features, machine learning algorithm is ready to filter spam. If a new email comes in, the text is tokenized and applied to the algorithm. So this is a block diagram. This is very important over here. So the incoming mail is processed, is pre-processed with the data, and a feature extraction is done. So we need to try to figure out what kind of features we need to like put into the pre-processed data to make it more, uh, distinguishable. And the training phase is done. Training is the testing and training data sets into 80 and 20%. The machine learning model is done, and after that, the classification of these mails happen. Machine learning models we're using, as I told you before, is the LSTM and naive based, and the classification is Hammer SAM. So these are the data sets we're using. We are mostly using data sets in Kaggle. So this is the structure of the email, as you can see. It will control the the email body and everything else. So after analysis of the data set, we found that the processing of the manipulating raw data to uncover useful insights and draw conclusions. So when we look at the data set, we have around 2,600 ham, which is good emails, and the rest is a spam. So we have around 4,600 emails of data set. So the other 1,400 is spam. I think 67% is mostly good emails. So these are the word clouds that are used over here. So all the spam words they use email address, business, stuff like that. The ham uses the regular words that we use. So data pre-processing is done. cleaning the raw data and tokenizing the raw data, and encoding and padding it. The algorithms as we use are autoencoders and LSTM compared to the naive-based algorithm. Autoencoders are unsupervised learning, um, artificial neural networks that attempts to encode the data by compressing lower dimensions, like bottleneck layer of code, and then decoding the data into constructed original input. The bottleneck layer holds the compressed representation of the input data. The number of units in the code is called code size. As you can see, the data is sent to the is done by the encoder. It is the bottleneck of the code is a latent space, so that is where the encoded data is present, and it is then sent to the reconstructed data, which is decoder. So as you can see, the encoder results are like this. So it has an accuracy of 0.65, which is not very efficient. So when we come to the LSTM, it is long short-term memory. It is capable of learning long-term dependency and also the key to vanishing gradient descent problem. So after doing the LSTM, we have an accuracy of 98.5, which is very efficient. And when you compare this to the supervised learning, it has a naive Bayes algorithm where we want to find the probability of a email spam given a certain word. We do this by finding the probability that each word in the email is spam and then multiply these probabilities together to get the overall email spam metric that is used in classification. As you can see, the confusion matrix of the naive Bayes is 66%, which is not very efficient in identifying the spam mails. Yeah, so this is an accuracy of the Gaussian naive Bayes and the multinomial naive Bayes. So when we put all the results in a box, so this is what we find that the unsupervised LSTM has accuracy of 9.8, and supervised multinomial and NB has 0.97. So this is how the total like emails, and this is just a quick result, a glimpse of how it is going to look like. I'm going to show you the code now. Okay, so this is the code that we're using over here. And so on in this part, we have to import all the necessary libraries such as pandas, numpys, NLTK, and sklearns. And the TensorFlow is library that we're using over here. It shows underlined because we need to import all of these, and I've already imported before. So you can just run the terminal in the terminal. So yeah, as we go through this, we have to download all the resources from over here. And this is the data set that we got from Kaggle spam detection. And the pre-processing of the data is done over here by, remove the punctuations, remove the stop words, anything. And applying the pre-processing, now to this data, we label the encoders. As I told you, the autoencoder is the algorithm. So we're going to encode it and fit into the transformation of the label. And you split the data into training and testing sets where we use 80% of training and 20% for testing. And you need to, and then comes the vectorization of for the naive Bayes. Vectorization helps to transform the data to a numerical form like a vector in the data. So which is easy for the algorithm to break it down and continue the vectorization. So then we use the xtrain vectorization and transform it into xtrain, x test vectorization, transform the x test, and you put that into an array. And then we train the naive Bayes model and we fit it into the xtrain vectorization by train and create the model. I can just start the code for you over here. So this is the part for the naive Bayes model. And after this part comes the LSTM model, which is the another machine learning algorithm that we're using. So over here, it is done to transform the data into simple values and like make into words so that each word will have an integer assigned to it. and it will make it easy for tokenization. So the maximum length that we're taking over here is 100. You don't want more than that because it's going to slow down the model. So we train and there's sequences over here, and then we build the LSTM model. So that and then we train the model by using epochs and the batch sizes and validation, and then we predict the model using X-test predictions, and then we evaluate the model. We would get a report like this. This report is for the naive base. As you can see, you get the precision recall F1 support and a confusion matrix as well. Now the code is running for the LSTM model. So we put 5 epochs, so it's going to run 5 times and test the data over here. And after building evaluating the LSTM model, we then plot the figures and for easy data visualization. And there's confusion matrix like this. This is a line chart for the LSTM model. The accuracy is around 9.9, and the law says the validation accuracy is 9.8. For the model laws, there's 5 epochs, so it keeps on going over here. And this is a confusion matrix for LSTM. As you can see, this is the matrix 959.6. As you can see this. So this is my project, and I've also tried to deploy it on the local host, and it does work, but it doesn't show the. It shows the API detection. It is working. So it's going to create development server. So I need to click on it so that it will show that the detection API is running. As you can see, Foundation API is running. So this is my project. If I have any questions, please let me know. Thank you.